Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon, ladies and gentlemen. Thank you for participating and joining our Zoom session. We just launched our session on YouTube just recently, about 1 minute ago. And can you hear me clearly, Dr. Hamdan and the rest? I see Dr. Amy Than.
Yes.
Okay, good. I will pin Dr. Hamdan and myself. Then thanks. I see Dr. Joseph Tanga from all the way from KK Sabah is with us here. And a couple of other friends, the Imitan and the rest. Thank you for participating and thank you for joining us. We will begin in 3 minutes. So now it's 2:27. We will begin sharp at 2:30 to allow for some other participants to join in and the rest to join us on YouTube. Alright, Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera and good afternoon ladies and gentlemen. Thank you very much for joining us. This is the first, the inaugural Malaysian Mangrove Research Alliance and Network monthly discourse for 2022. As you all remember, we have done this in person in 2019, where a series of speakers have presented live during that time, way before the pandemic. But now we are trying this new approach of getting in touch with all our colleagues, all our friends, all fans of mangrove and mangrove research throughout Malaysia and throughout the world, through a new lineup of 11 speakers for this year. And to kick off, to kickstart this Malaysian Mangrove Research Alliance and Network monthly discourse for 2022, we are proud to have geospecialist Dr. Hamdan Omar from Forest Research Institute of Malaysia to share with us his experience, his vast experience. I think he has been with FRIM, for the Research Institute of Malaysia, for about 14 years, I think 2008 kan, Dr. Hamdan. And his vast experience in research on remote sensing and GIS application in studying mangrove and other forested ecosystems and habitats throughout Malaysia. His publication is outstanding. His network, international and international network, is outstanding as well. And today he will be sharing with us I think the updates, one of the latest updates of his research, in which he applied his skills, knowledge and experience in understanding the use of Earth observation satellites to monitor, to identify the habitats and ecosystems, to map and to monitor mangrove forest at national scale. And his findings actually has been published in a few platforms. One of the key outputs is the mangrove of Peninsular Malaysia, status of mangrove in Peninsular Malaysia, or maybe Malaysia. Maybe Dr. Hamdan will update us later, and in a few journal articles as well. So today we will get first-hand information from Dr. Hamdan Omar. So thank you, Dr. Hamdan, for accepting our invitation to share with everyone, participants in this Zoom platform, as well as our friends on YouTube, about your experience, about your these research findings as well. So for all of you who are not familiar with with MyMangrove or the Malaysian Mangrove Research Alliance and Network, you can check out our Facebook groups. You can join and be part of MyMangrove by sharing, by posing questions, by sharing news and updates from your local area, from your surrounding, or through your networks as well. So as you all know, MyMangrove actually started off in 2017 with a group of researchers dedicated to mangrove. But then we realize as we go, and we understand that working in mangrove, doing research, is not about dealing or interacting with scientists alone. We know for sure it needs collaboration with local authorities, government authorities, with corporate organization, and more importantly, local communities. So we have not just scientists, not just practitioners, managers, we also have mangrove fans throughout Malaysia and throughout the tropics, as well as throughout the world, because we know there are our counterparts all over the world, outside, even outside the tropics and the subtropics. So there you go. Interest on mangrove is gaining attention, gaining traction. A lot of efforts are being put to conserve and protect mangrove. So, but then we have to do it with the support, strong support of science. So this is what we are doing through MyMangrove Monthly Discourse, sharing of knowledge, scientific inputs to assist in protecting, conserving, restoring, and managing our mangrove habitats and ecosystems. So there you go. So thank you very much. Check out also the other 10 speakers that will be speaking this year. So every month we will have we will feed you, fix your needs and crave for mangrove knowledge and education and input. Yeah. So without further ado, we will have Dr. Hamdan. So how we organize MyMangrove monthly discourse is we will allow the speaker to speak for about 30 minutes, 45 minutes or 1 hour maximum. And then we will have another 15 to half an hour question and answer and discussion. So this discussion can be focused on the presentation, or we actually try to promote initiation of collaboration with the speakers. So Dr. Hamdan is open for ideas, for suggestions, to do further research with regards to his skills and contribution towards the advancement of knowledge on mangrove, mangrove systems and mangrove research. So there you go, Dr. Hamdan. You can now share your slides, and we will have it depends on you, maybe 45 minutes to 1 hour, and then we can have a question and answer. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and very good afternoon. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. So first of all, I would like to thank to Dr. Adri for inviting me to start up this session for the year 2022, and I would like to congratulate you as well for providing us such a wonderful platform for us to get some updates and information about the mangrove ecosystem that we have in Malaysia and throughout the world generally. And I would like also to wish you all Happy New Year 2022, and hope that this year will be going better compared to the last few years. So today I'm going to talk about a topic which actually was given by the organizer on Earth observation satellite for mangrove identification, mapping, monitoring at national scales. And this session will be conducted orang kata santai-santai lah, tak ada formal sangat. So maybe after this, if you have some question or some things that need more clarification, please do ask me. And it is a pleasure to have you all here. I can see some familiar name, and a bit nervous because some names are also expert in mangrove. So it's okay, but we going to share. We will share what we have, and if you have some new ideas and some new recommendation, please speak up after this. All right, my presentation outline will be covering some introduction to mangrove, and then I will talk about some fundamentals of remote sensing and also the Earth observation satellite. Maybe some of you are familiar with the term remote sensing and also Earth observation, but maybe some of you is quite new in this system and this technology. And then I will go into details what we recently conducted on mangrove ecosystem in Malaysia, which is the mapping and also monitoring of mangrove habitat mapping and also monitoring in Malaysia by using optical remote sensing system and also microwave or radar remote sensing. So before we go to the details on mangrove, I would like to inform you all that we how much the forest that we have in Malaysia right now. So before that, we would like to define what the forest is, at least the definition that is used in Malaysia. So forest includes all land with woody vegetation, which are consistent with a threshold, with a minimum mapping unit of 0.5 hectare, and with a minimum ground cover of 30%, or minimum height of maturity of 5 meters. So this is the minimum threshold that we use to define a forest. So whenever you see an area that meet this threshold, then you can define that as a forest. So in Malaysia, right now we have about 18 million hectares of forest, which comprise of which are divided into 3 main categories, which are inland forest or deep tropical forest, and then peat swamp forest, and also the topic that we're going to talk today is mangrove. So altogether there are about 18 million hectares, and of course the majority is the inland forest, and it is followed by mangrove, by peat swamp, and also mangrove. And in terms of percentage of forest cover in Malaysia, we have now about 55%, which is covered by forest, and the rest consisting of agricultural land and also the development areas. So now we are going to touch a bit on the satellite, how the satellite system works and how the Earth observation satellite works. So satellite is actually the object that orbit the Earth. It moves in a circular plane at a distance from the Earth. So you see here that the moon is a natural satellite by definition. And also the Earth, which is orbit the sun, is also we can call it as a satellite. So, but these are the natural satellite. So whatever object that orbit the Earth, we call it a satellite. And the word satellites now in this term we refers to a machine that is launched to space and move around the world to capture or to capture the Earth phenomena and also events, or we call it as Earth observation. And did you know that the satellite accelerates at 20,000 kilometers per hour, which is about 60 times faster than the bullet train in Japan? So the satellite moves very, very fast in the outer space, and it's flying about 700 kilometers from the Earth's surface. So this is in terms of Earth observation satellite. There are many satellites in the outer space, and the satellites that observe or that see the Earth's surface, we call it the Earth observation satellite. So it works like we put a camera on a platform and then fly through on the over the Earth's surface, and then capture the picture of the Earth's surface. So that is in general terms how the Earth observation satellite works. And then on the Earth's observation satellite, they will mount a sensor or camera system that can capture the photos or the image over the surface, and then we can process the image in our computer. And in terms of optical image, there will be three basic colors, which are red, blue, and green, and which you combine these colors will create more digital numbers, which represent the features on the Earth. So basically, whatever image that you use, the basic color is only three: red, green, and blue. But when you put on the computer and then process that, it can produce about 65,000 colors, or we call it grayscale. So these are the 16-bit image that is used to produce colors that you can interpret, and also how you read the image. So that is in terms of color. And did you know that our eyes also is one of the remote sensing system, which is a gift from the God. We have eyes that can also see the object and also can differentiate many objects and also many colors. But did you know that how many colors that we can differentiate? So basically, the general observation says that we have ability to differentiate about 10 million colors, different colors. So if you remember just now that the computer system only can differentiate about 65,000 colors, but our eyes have ability to differentiate about 10 million colors, which is much powerful than the computer. So you should be grateful if you can see, because it is a priceless gift that you can replace if you lost them. So that is how the concept of remote sensing. And then when it comes to the computer, the image is formed in terms of pixel. We call it pixel, and a combination of pixel with different intensity or different colors will create image. So image is produced from pixels. So what pixel is? Pixel is actually come from the word picture elements. Picture element, pixel. So the pixel is actually come from the word picture element. So it is similar to the photos that you capture from your phone or your camera. It produces image that if you zoom into a certain level, you can see a square dot, which is a pixel with different intensity and also with different colors. So from there, you can interpret what is the image tells you. Okay, now we move to the remote sensing. So why we use remote sensing in forest assessment and also many other applications? Because it provides fast and less expensive observation. So you can get a data for a large area with not very expensive in terms of cost. And then in terms of precision or the accuracy, also is reliable in terms of data that you can get from remote sensing. And in terms of forest cover, it provides forest cover map with acceptable accuracy for small areas, and also for large area, depending on the system that you use, and also depending on the scales that you are going to map. So in this case, we are going to map or monitor the mangrove habitat ecosystem in Malaysia. So in this case, we are going to talk about national scales or regional scales level of mapping. So what kind of satellite system that is suitable for that kind of application or for that kind of objective. And there is a few common consideration in forest assessment by using remote sensing, which are cost, of course, and then accuracy, and then scale. So scale is also important. Is this your study area is very big or very small? And then how big is big and how small is depending on the remote sensing or the sensor system that you are going to use. And then time. Time is here is the two aspect of time, which is the monitoring time in terms of so from when to when you want to see the changes or you want to monitor the area, and then the time of processing. How does the system will takes in terms of data processing and whatsoever to produce the map. And then rapidity and also replicability of the data that you use for the forest assessment. And here there is a trade-off between cost and accuracy. So whenever there is a choice or a system that you can make, you will go for the best, of course, for the best. But sometimes the best quality will come with a cost, of course. And then the most recommended one is the low in terms of cost, but it can provide reliable or acceptable accuracy in terms of precision. So we are going to talk about this. And then it is related to the cost and also scale as well. So there is hundreds of satellites in the outer space that you can use in terms of data, but some data produce images that can meet some purpose. So for example, if you want to see details, features on certain object, then you can go for higher resolutions. But of course, the image that you're going to use, you need to buy and you need to purchase that. And then if you go for larger scales, let's say if you want to see for that covering Peninsular Malaysia or maybe Sabah and Sarawak, maybe you can go for free access satellite data, and then the cost will be much lower than the higher resolution. So this is how we work with the satellite system and also the objective of the study that we are going that we want to achieve for a specific purpose. So in terms of remote sensing, there will be passive and active remote sensing. So what is active and what is passive remote sensing? So maybe some of you, we are going back to school, because this is the basic of remote sensing. But maybe some of you, this is new. So please welcome to listen to my class. All right, so passive sensor is actually known as also known as an optical sensor, which can only be used when there is a natural light or natural energy is available. So in this case, if there is a sun that produces lights, and then the satellite can works. So it captures the image that depending on the light. So in this case, it cannot see in the dark. So in other words, the passive sensors only can work in daylight. So if there is night, the sensor cannot work because it cannot capture the image. So it works very similar to the camera that you have. So if you capture image or capture photos on the light, then you can get the result. But if you capture photos in the dark, then you can get nothing lah. But different from passive sensor, there is an active sensor, which is they provide their own energy source for illumination. So in this case, the active sensors refers to microwave system, or we call it a synthetic aperture radar system. That is also available, and it is also widely used in vegetation mapping and monitoring throughout the world. So I'm going to describe these two systems in terms of mangrove ecosystem mapping in Malaysia. So you can see here there is a lot. There is 100 and even 1,000 of satellites in the outer space that works for Earth observation. So this is example which is owned by European Space Agency only. So even for ESA only, there is tens and hundreds of satellites in space. But there are many other satellites which is owned by USA and also Japan, China, and also France. So if you can go to the outer space, there is a very busy traffic in terms of satellite movement. But this satellite works on its unique orbital height and also orbital speed. So they don't tak berlanggar lah each other. And there is also the other satellites that works in the outer space, including the communication satellite, weather satellite, and also the geosynchronous orbit satellite, which is the GPS satellites. And basically the Earth observation satellite works within this orbit height, which is less than 2,000 kilometers. And normally it is about 700 to 800 kilometers from the Earth's surface. So it's quite high, because if you bought the flight, it usually fly around 10 to 12 kilometers from the Earth's surface. But the Earth observation satellite can fly about 700 to 800 kilometers away from the Earth's surface. And then going far away, further, there is a International Space Station satellite, and also the communication satellite, which is much higher altitude compared to the Earth observation satellite. So each and every satellite has its own function and its own purpose. So we are focusing on the Earth observation satellite today. So now let's see the principles on how the remote sensing captures the image and also captures the event on Earth. So basically, the optical system, why they call it optical? Because it involves the visible spectrum in their sensor system. So this is the wavelength for the visible wavelength, and there is also some infrared wavelength included into the sensor system. And there is also microwave, which is a much longer wavelength, is used in Earth observation satellite. So the longer wavelength is the frequency, radio frequency, and also the wave that is not used in remote sensing. So why? Sorry. And that is these are the common satellites, optical satellite that we use in our research and also in our daily use. There is a free satellite, and also there is a satellite that you need to pay for the image. This kind of these are some of the satellite that is commonly used in remote sensing. Yeah? Okay, so we finished about remote sensing. So hopefully you can imagine how the remote sensing works and how we observe the Earth from the satellite. So now we move to the mangrove, the main topic that we're going to talk today. So before we go further, we would like to I would like to define what is the mangrove. So maybe all of you knows about mangrove, but maybe some of you are not very familiar about mangrove. So mangrove forest is a forest that is salt tolerant tropical shrub or trees growing in areas such as rivers, estuaries, or tidal marsh that are covered by the sea at high tide. So the ecosystem or the habitat of mangrove is always near to the shore, near to the sea, and also near to the estuaries ataupun kuala-kuala sungai. And mangrove plants include shrub, ferns, trees, and palms. The forest is a form of vegetation that connects the terrestrial forest with the sea and can be referred as the forest between the land and the sea, with a range from 0 to 5 meter above the mean sea level. So it's a low-lying forest, or in the habitat is reside on the floodplain of the topography, and then it always reside near to the shore and also the estuary. So you cannot find mangrove in the mountain or in Cameron Highland or Genting Highland. You cannot find mangrove. So you can only find the mangrove along the coastline of our country, Malaysia. And in terms of species, there are records that saying that we have about 38 exclusive species. So there are two categories of species, which are exclusive species and also associate species. So maybe some of you are familiar with this. But recent findings told that there are actually 41 species, exclusive mangrove species that we have in Malaysia, and mostly can be found in Langkawi, and the rest can be found throughout Malaysia. So we have about 40, generally we have about 40 mangrove species in Malaysia. And these are the locality or the places that you can find mangrove in Malaysia. And did you know that Malaysia is the second countries that has the largest mangrove forest in Southeast Asia after Indonesia? So Indonesia has a bigger tract of mangrove, and we are the second countries that have the largest mangrove. And most of them are in the eastern region of Malaysia, which are in Sabah and Sarawak. So we can see the statistic after this. So now we move to the satellite system that we use to map and also monitor the mangrove ecosystem in Malaysia. So in this case, we use Landsat. So Landsat is owned by the United States, and it was first launched in 1972, starting from the first mission, which is called Landsat 1. and continue until now. There is Landsat 8 still operating in the space, and they plan to launch the Landsat 9 in last year, but due to the maybe some reason the launch is delayed to 2023. So in terms of continuity of the data, you cannot find in from the other satellite. Only Landsat can produce that kind of historical data that can produce the old data for you to analyze and to monitor the forest ecosystem, in this case the mangrove. So we use this data and we process the data to produce the mangrove ecosystem habitat mapping and also monitoring. And another one is the sometimes ago you need to buy the data of the Landsat, but now you can get it for free. You can download it for free. So these are the example of an image of Landsat. So basically, the satellite captures the Earth's surface in a snapshot. So the sensor scans the Earth's surface and then produce an image in a snapshot like this. So we call this scene. So to produce images that cover the whole Malaysia, we need a number of scenes. So these are the number of path and also the number of row. So the number of path and the number of row is refers to the orbit track or the pathway of the satellite. So you can refer to that number to locate where is your area is. So in this case, we need to have at least 27 scenes of Landsat to cover the whole Malaysia. But let me skip one slide. But the problems in tropical countries, including Malaysia, is the cloud cover. So we always covered by cloud, so which become a problem, which will become the biggest issue for the optical images that we need to tackle. So in this case, we need to have a process where we need to mask the cloud, and when we take out the cloud and only leave the features that is clear from cloud, and then we need to combine, or we need to mosaic it into a perfect image without cloud like this. So in this case, we need to have 5 different images which were captured from different dates to produce an image without cover. So that is the challenge. So that is the challenge when we are working in tropical countries, including our countries, Malaysia. But if you are working in, for example, in China or in the Middle East countries, the cloud cover is not really a problem for them. So from this process, we need to have at least 145 scenes to cover the whole Malaysia that with the image without cloud cover. So you can imagine one scene, the size is about 1 gig, and then 145 scenes, you just multiply by 1 gig, is about 145 gigs of gigabytes of data. So we are dealing with a big data, and we need to have a powerful computer to process this. And this is only for one-time acquisition or 1 year acquisition. If you want to monitor, or if you want to have another year, then you have to repeat the same process, and you have you're going to have a similar number of scenes to cover the whole Malaysia. Right. So from this process, we produce a seamless, we call it seamless mosaic of Landsat. Seamless means a smooth and without the disruption of cloud cover. Even though we select the best image over the certain periods or certain time, there are still cloud cover appear on the image. So that is the biggest challenge that we face. The first one is and then the second one is we need to deal with the big data. Right. So these are the process that we went through to produce a perfect image or the beautiful image without cloud cover. It takes some time, but we have software to do this, and right now we have many scientists that are working on it. They have produced an algorithm to do that automatically. So we just use that. But of course, you need some time to process, and you need a powerful computer to do that. So now let's move to the how the interaction of electromagnetic spectrum with the mangrove ecosystem. So basically, when you see the leaf of mangrove trees, the thickness of the leaf are actually different from the other species, and the leaf are thicker in terms of the thickness, and the chlorophyll content of the leaf are actually higher than the other species. And if you can see here in the left picture is the common spectral signature of the Earth features of the Earth, the common Earth object. So for the vegetation, there will be always a pattern like this, and these are the reflectance at certain wavelength. And then this is for the soil, and also this is for the water. So these are the visible region. We call it visible region, which is split into the main colors that I explained just now, which are red, blue, green, and also red. And normally the reflectance of the vegetation or the leaf are higher at the green region, and that is why you see the leaf are green. That's the reason why, one of the reason why leaf are green, because they the cellular element in the leaf will actually reflect the green region of electromagnetic radiation, and they absorb blue and also red. So they absorb blue and red for their photosynthesis process, and they reflect green. And in terms of if you go higher than if you go longer wavelength, which is NIR or near infrared, the reflection even stronger than the green one. So you can see here there is a higher reflectance in terms of electromagnetic radiation in near infrared region, but you cannot see. You cannot see near infrared region. Your eyes cannot see, but the satellite is designed to capture or to read this reflectance. So you can only see this one, visible one. So that is why you can see most of the leaf are green because they reflect the green region, and they absorb the blue and red region in terms of electromagnetic radiation. So that is the concept of how the satellites or the image is captured. So now we move to the mangrove ecosystem compared to the other vegetation that we have in Malaysia, for example. But also in the other place, the patterns of land use is also quite similar. So you can see here, we took sample from the image of the mangrove, which is at two different conditions. And also the other vegetation, dry inland, also oil palm, and also the other features like urban and also the water body. So you can see here that the blue graph or the blue line here represent the reflectance of mangrove ecosystems as compared to the other ecosystems. So you can see that here the reflectance is quite lower because why? Because the near infrared is very sensitive to the wetland ecosystem, or very sensitive to water. The near infrared cannot reflect the energy on water. So in the other words, the water will absorb the near infrared region of electromagnetic radiation. And so because the mangrove reside on the wetland ecosystem, that's why the readings or the reflectance in terms of near infrared region is lower than the other ecosystem. So that is why we analyze and interpret the mangrove ecosystem from other vegetation.
These are the vegetation
indices
that we.
So there is a method that we can use to take out or to classify or to separate the mangrove ecosystem from the other ecosystem. So for example, here we have the raw image without any processing. So even though there is that image is displayed in a natural condition without any process, we can really see the mangrove ecosystem. But in terms of when we go to the computerized processing, we need to have the pixel number or the value that represent the mangrove. So we need to separate them from the other features. And then we need to have some process or some enhancement process. We call it, we use vegetation indices or vegetation index to produce an image that that show or that enhance the object that we need. So in this case, we need only mangrove. So there is a few vegetation index that I just shown from the previous slide here. So we use that to produce this kind of image. So if you get here, then the classification process after this will become much easier, right? Because you can really differentiate, or you can really separate the mangrove ecosystem from the other features. So we have here agriculture, we have the other inland forest, we have ocean, and also we have the other vegetation on the image. So we need to separate them. And then once you get that information, or once you get the confirmation, you can execute, or you can run the classification process, which is to extract, or we call it to classify the mangrove ecosystem. So here we did some processing, we did some classification process, and from there we can get a layer, or a separate layer that only comprise of mangrove ecosystem. So the red region or the red polygon actually shows only the mangrove. So this is how we did. So from the image, we do the classification, and after the classification, we convert it into vector format for further processing, for analysis, and also to count how much the area that cover this particular part. And we did that process for the whole Malaysia, and it takes quite some time, but we actually enjoy doing that because we understand the process, and we know how to identify that kind of system on image. And besides, we also conduct some ground truthing activities to confirm on the ground. So we travel to all the mangrove patches that we have in Malaysia to confirm whether that is a really mangrove or the other ecosystem. So that is why this project or these activities took us about 2 years to complete. So the statistic of mangrove in 2017 can only be published in 2020, 3 years after that. So we need to go through that process, and that's why we need some time to confirm or to publish these figures. And we're glad to see that our ministry is using these figures for their reporting, and now they are asking us to update this for the latest information for this year mangrove, for this year's coverage on mangrove in Malaysia. So I presented this a few times, maybe some of you have seen this. So we have about 629,000 hectares of mangrove in Malaysia. And the largest is in Sabah, which comprise of 60%, and is followed by Sarawak. And in Peninsular Malaysia, we only have about 18%, which is covering about 110 or 111,000 hectares of mangrove. And most of the forests, or most of the mangrove ecosystem in Malaysia, are already gazetted or already secured in terms of management. So most of them, or 85% of the whole coverage, are actually the permanent forest reserve. So the rest, or the remaining area, is under the state land or the alienated land, or the land that is owned by personnel or company. And we can see here that all region has already taken action in terms of the gazettement or reservation of this area. So now we see move to the threats, or we move to the monitoring aspect of the mangrove coverage. Just now we talk about mapping, how we produce the map and how we identify the areas of mangrove in Malaysia. And now we move to the monitoring aspect of the mangrove. So when it comes to the monitoring, you need to have at least 2 different time of image or data acquisition or activity data, because you need to see whether there is a loss or there is a accretion of the mangrove ecosystem. And from there you can see the threats or the costs of, or the drivers of mangrove loss. So in Malaysia, and I think this is common to the world, that the most common drivers of mangrove loss is the logging, agriculture, aquaculture, pollution, coastal development, and also maybe some of them impacted by the climate change. So when you have a series of image or a series of data or activity data, we refer to here as activity data, you can really see the changes. You can measure the changes from one time to another time. So in this case, we put here about 4 series that have about 10 years different from one to another. And here I'm showing you the mangrove ecosystem in Merbuk, Kedah. And the most significant or the most visible changes was caused by the aquaculture. So you can see here that from year to year that there is a development of aquaculture or the shrimp ponds that was built in mangrove ecosystem that that was built to supply or to meet the demands on the seafood supply. And then the second one is the agriculture. So I cannot remember where the patches is, but I think it is in Sabah, where there is some mangrove expansion that was occurred between year 1990 to 2017. So you can see from the mangrove ecosystem, it slowly encroach into the mangrove ecosystem, and then now it's become a permanent changes where where there is from mangrove to the oil palm plantation. And then the third one is the land development. So we actually cannot run away from these activities because we need a space to develop. So the third factor is in Pulau Indah. So we can see from 1990 where that is covered by mangrove, and then it's slowly developed by residential areas, and now mangrove only left small patches, and maybe some days later a mangrove will no longer available or will no longer exist in this pulau. So that's it, some example of the factors of deforestation or mangrove deforestation that is occurred in Malaysia. And then the fourth one is the coastal erosion. So the coastal erosion is not happening everywhere, but some areas facing this kind of issues or this kind of problem where there is coastal erosion. So you can see here that the red polygon showing the mangrove extent or mangrove forest in 1990, and then it was slowly eroded, moving towards the land, and now only small patches of mangrove left in this area. But at the same time, there is some accretion or some additional areas that are developing in this coast region. So you can see that these are actually a dynamic process where there is erosion, there will be some accretion occur in the nearby areas. So there is a natural process that you can actually control that, but by using this technology, you can see how the process is occur. So similar to the Pulau Kukuk. So now we see the statistic on how much mangrove that we have some times ago, and then how much mangrove that we have now. So we can see here that 30 years ago, we have about 650,000 hectares of forest, and now only left about 630,000 hectares. So we lost about 20,000 hectares here in 30 years. So we can calculate that changes and we can come up with the rates of loss, with rates of deforestation in terms of mangrove from year to 1990 to 2017. And the rates of deforestation was estimated at about 0.13% per year. So this is a similar phenomena happen, which is accretion, or the additional mangrove ecosystem that were built naturally from the erosion and accretion process. So this is in Penang. So we can see here that some times ago there's only mud flat here, but now it's becoming a mangrove ecosystem that will develop from natural process. It slowly happened. It took about 30 years from the mud flat to the forest. So it occurs also in some places. Same happened. This is in tak ingat kat kawasan mana, tapi in Peninsula Malaysia. You can see where there is a mud flat here, and then 2000 it slowly developed. The forest was slowly developed, and then it become now it become a forest ecosystem. And whenever there is a mangrove ecosystem, there will be aquaculture industries that will develop there. So you cannot run away from this situation. So this is similar happen in Sarawak. And these are the system that was developed by Global Forest Watch, which is taking advantage of optical remote sensing. In this case, the Landsat system. They come up with a system that collect information from decades ago until now, and then they analyze the changes, and then they put in a platform that everybody can see and everybody can download this. So these are the example of the Earth observation satellite application that is put into a beautiful and a complete comprehensive platform for us to see and to observe the what is happening on our forest. And in terms of publication, we produced some publication. This was in 2012, which cover only Peninsular Malaysia. And then we also did a publication on the Ramsar sites in Johor, which are taking advantage of a high resolution satellite image. So because we cannot cover the whole Malaysia by using high resolution satellite image, because you need to purchase this, and the cost is quite high. So we concentrate only on the Ramsar site in Johor. And then recently we came up with a mangrove extent mapping and monitoring in Malaysia. So this is what Dr. Audrey said in the introduction. These are the publication that was produced from the Earth observation satellite for mangrove mapping and monitoring that we produce for Malaysia. So we don't have this before. So this is the first one maybe that we produce for the nation. And our ministry is using this publication, the figures that is reported in these books for the reporting. Okay, now we finish about the optical system. Now we move to the radar or synthetic aperture radar system, which is the active system. So active system actually using the microwave, which is the in terms of electromagnetic spectrum, the wave are higher, longer than the optical one. So the system is not affected by atmosphere. So in this case, you don't worry about the cloud cover because it can penetrate the clouds, and also it can operate day and night. So it doesn't depend on the light, but it produces its own energy to emit, and also they capture or record the returns. So in this case, you can work in the night, able to penetrate the canopy also, depending on the band. So radar system or a SAR system that is developed for Earth observation is comprised of several channels or several bands, which are the common one is X, C, and L. So each and every band has its own wavelength. So the longer the wavelength, the lower the frequency, and the shorter the wavelength, the higher the frequency. So that's how the system was developed. And actually the SAR system works slightly different from or totally different from the optical system. So they produce their own energy, and then they record the returns or the backscatter in terms of the energy or the strength of the returns. So in the other words, the sensor records the system records the energy or the strength of the returns. And it needs always to look in a slant direction. Why why this system is designed that way? Because the radar system will need to have this kind of look or this kind of angle to see to observe the object. And because if you look at the nade point, or if you look at the central point like this, the signal will become confused, and which we call it a crosstalk effect. So the receiver cannot read the returns. So that is why it always look in a slant direction. And depending on the wavelength that they use on board, the interaction between the wave and the object will be also different. So now let me see how the microwave system responds to the mangrove ecosystem. And again, because the mangrove system is reside on the wetland ecosystem, it will give advantage to the SAR system to recognize or to identify the ecosystem, because the microwave is very, very sensitive to the moisture or to the we call it the wetland ecosystem. So now the most common the common band that we use is X, C, L, and also P. So it'll be depending on the length of the wave or the wavelength of the SAR system, and the penetration levels will also affected by the wavelength. So let's see, if you use the short wave X, it only can penetrate some centimeters of the canopies, and if you use the longer wavelength, it sometimes can go up to the floor of the forest. So that is why most of the wetland ecosystem will become darker, or will become we call it will become dark in terms of image. And then the polarization or the attenuation of the movement of the wave from the sensor to the Earth's surface can be also arranged or can be managed into different direction. So in this case, most of sensor are using H and V. H is horizontal and V is the vertical. So HV, which means that the sensor will emit the energy in horizontal direction, and then it captures the returns in vertical direction. And HH is the sensor emits the energy in horizontal direction and receive also in horizontal direction. So the we call this polarization in terms of direction of the wave. And the polarization also plays roles in differentiating or in separating different features on the Earth's surface, because the strength of the returns will be different in different direction. So we see here that cleared land, plantation, and also agriculture, crop, and forest will have different tones of image and different returns, different strengths of returns. So that is why some of the image will become darks and some of the image will become light. So the lights mean the returns is very strong, and the dark image, the return is very weak. So in this case, you can see here that the water body is always dark because the microwave cannot give returns when it interact with water. So in other words, water will absorb microwave. So whenever there is absorption, so there will be no return. So that is why the returns will become zero or will become very weak in wetland ecosystem or in water ecosystem. So that is why we use this advantage to identify or to recognize the mangrove ecosystem by using SAR system. So now you see here that an image that shows a portion in Sabah, which is displayed in HH polarization, HB polarization, and the classification products. So we use specific algorithm or specific equation to identify this forest. So we need to have at least two polarization to do this. And in a naked eyes, you cannot really see the boundaries of the mangrove. You know that the mangrove will become darker as compared to the other features, but you cannot really see the boundaries. So you need to have a computerized method to calculate that for you. So this is one of the example on how we classify the mangrove ecosystem on SAR images. And then if you have a different polarization, you can play around with the polarization. So for example, you can manipulate that. So you can for example, you can plus or minus, or you can divide, or you can produce a ratio between that polarization to produce different sets of data that will show you the condition on the ground. So this method is used to separate or to classify basically the density or also the biomass of mangrove ecosystem. And when you have several dates of SAR image, you can produce image in colors. So you can combine that, you can put in different RGB combination, and then you can display image on in a color. So basically SAR image is black and white, so you cannot really see the colors on SAR image because it always come in black and white. So you need to have more data sets with different dates to produce colors or to produce image with colors. So that is the difference between optical and also SAR system, and how we use both system to identify, to accurately identify mangrove ecosystem in Malaysia. So in terms of coverage, it's similar to Landsat. So in this case, I'm showing you the Japanese JERS and also the ALOS PALSA. So JERS is stand for Japan Earth Resource Satellite, and ALOS PALSA is the Advanced Land Observation Satellite by using phase array L-band SAR, which is owned by Japan. And the coverage is also worldwide, which means that you can get the image anywhere in the world by using this system. And then there is a team from different parts of the world, and they work together to come up with they call it Global Mangrove Watch. So this system was developed purely based on SAR system or the radar system. So they use JERS and also PALSA satellites to map the mangrove throughout the world, the whole world, and then they put it on the platform that anybody can see, can read, and also can download, even download the data. So in this case, we focus on Malaysia. That they said that in Malaysia there was about 5,000 kilometers squares in 2016 of mangrove cover in Malaysia, and then they report this in this platform by using the PALSA system. So now we see the difference of the estimates of mangrove ecosystem in Malaysia. From one is the Landsat, and another one is the Aperture. So we can see here that there is some difference in terms of the total estimates of mangrove cover in Malaysia. So we can see that the Landsat produce about 6,000 kilometers square, or about 600,000 hectares of mangrove from 2017, which is from my study. And then this one was from the other study from the Mangrove Watch, that they use PALSA, and they get about 500,000 hectares of mangrove in 2016. So there are about 1,000 or 100,000 hectares difference of the estimates that were produced from these two systems. So we can see here that some of the features, or some of the forested areas were classified as a different forest in terms of the identification or the recognition of the area from the SAR system. So that is why the estimates produced from SAR system was slightly lower or slightly underestimates as compared to the optical system that we use. And then plus the other reason is they depending 100% on the satellite ecosystem, satellite system, without going to the ground and to verify on the ground. So that's why I am not using this results, because we cannot really depending on the classification result, because there is some mixings in terms of features between mangrove and also the other features. So that they are actually mangrove, but was classified as other features in this system. So these are kind of limitation when we are using different kind of sensor system for mangrove mapping in Malaysia. So we come to the conclusion. So why there is some inconsistency or some difference in terms of mangrove extent? One, because there is no standard methodology. In this case, you can use the other methods. For example, you can use segmentation, or you can use the other machine learning system to classify the mangrove. Maybe the estimate will become different. So depending on the operator of the system that they use, and then the method or the technique that they use in classifying the mangrove ecosystem. And then the second one is there is also no clear-cut demarcation between the extent of water bodies and mangrove and land due to the tidal inundation. So some of the image is captured during the low tide, and some of the image during high tide. So you cannot see you cannot really see the boundaries or the cutting point of this effect of this situation on the satellite image. And then the third one is the types of the satellite sensor system also contributed to the difference in estimate. So as I showed you all just now, that we use two systems, and this two system even conducted on the time that is quite similar, but the result is different. So it is because the satellite sensors that system that we use. And then the fourth one is the spatial resolution or the spatial resolution of the satellite imaging. So in this case, we use medium resolution satellite image. So for Landsat, the original resolution was about 30 meters, and then the pulsar system is about 25 meter resolution. So it's quite similar for both system, and then it's classified under the medium resolution satellite image. Suitable for a large scale mapping. So we are talking about Malaysia. So we cannot use a really high resolution image to cover the whole region. And that is also contribute to the difference or the accuracy of the estimate. And then the last one is there is no clear distinction of boundary between associate mangrove species and also the exclusive mangrove species. So we rely on the ecosystem condition. We don't know what is the species really is on the ground, but we depend on the ecosystem, where there is a wetland, then we can classify both on based on the natural condition of the mangrove ecosystem. So I think that's all my lecture today. So hopefully you join my class, and if there is a question, please welcome.
All right, thank you very much. Thank you very much. Okay, so now for 1 minute, the time then go get your coffee or your drinks. I'm pretty sure you're getting thirsty by now. So Yes, you've actually opened up my mind, and I'm pretty sure many of us are very excited looking at these beautiful photos, yeah, images from satellites. And of course, you answered many of my questions already. Actually, I was about to ask you about the discrepancies in data and reports. We know that there are so many global studies using global databases, and of course also differences in reporting within the national context. Yeah, using I mean, now we're using satellite imageries, yeah, and using radar as well. But previously, our researchers were using topo map and maybe aerial photograph. Yeah, so we've
Yes, right.
seen change. I mean, there's so many different numbers, and I think, yeah, you've already explained on how and why these discrepancies exist. But then I'm actually very thankful to you and your team at FRIM as well. I'm pretty sure many of us are the same, uh, for the proactive measures, yeah, they can maybe supported by the ministry and maybe also forestry department, for us to have one good reference to tell the world on the amount of mangrove that we have currently. Yeah? And it is good also that we are receiving this support. You and your team are receiving support from ministry to update this information from time to time. Yeah? And this is very important, as you've highlighted. That is very basic, fundamental, right? We need to know where our mangroves are. We need how much area we have. Then we can actually facilitate further research, for example, on biodiversity, on ecosystem services, as well as on the management strategies. We all agree that, and you've already also highlighted that the amount of mangrove being protected and not protected at the moment. So I reckon another step that we are going to take together would be to identify strategies for non-protected areas on how on the way forward, right? So of course, many of us would like to suggest for these non-protected area to be protected, right? So, but then of course it has to. I mean, we have to also consult the state authorities, right? Because they are the owner of the land, basically. Yeah? So yes, briefly, and then you also answered earlier on my question about and cloud tides, yeah, on how they affect data acquisition and, as well as processing. So there you go. To all listening and watching today, it is not a simple work. Yeah? Working in mangrove is already super hard. Even working from space, yeah? Looking at mangrove from space, analyzing is also very hard. So it is not an easy job doing research in mangrove, but we have all of us here, all of you dedicated researchers still, yeah, working hard to understand our mangrove ecosystem. So thank you very much, Dr. Hamdan. I would like, actually, there are some questions that are related to your presentation. Actually, there's one earlier from yeah, Abdullah Al Asif. He was asking how many Malaysian satellites are orbiting now for observing or dealing or to monitor Malaysia and particularly Malaysian mangrove. If you have that information, Dr. Hamdan.
Malaysian satellite.
Yeah, maybe not limited to Malaysian satellite, I think. Yeah, I think the many hundred satellite that you mentioned, actually, maybe all of them are looking on Malaysia, or specifically maybe contributing to your study.
Yeah, most of the Earth observation satellite is designed to cover the whole globe. So it will be launched, or it will always working on the sun synchronous orbit. In the other words, we can say that this satellite will cover the entire Earth, the entire Earth. So whenever you are in the Earth, you can get the data. But if the question is asking on the Malaysian satellite, actually we don't have yet. We don't have our satellite yet. Some times ago, there is a Razak set was launched in the space, but it only works for a few days and then it's malfunction. And then now our space agency is working with some international bodies to design and to develop our own satellites. So hopefully within a few years in the future, we can have our own satellite.
Nice. Yeah, I just got to know Razak site didn't work after a few days. That's yeah, quite frustrating. But then, of course, with new technology, and we hope to have more scientists also working on developing like a specific satellite for Malaysia to assist us with research. Yeah? And yeah, next question from Dr. Harinder Rai Singh, our good friends, Dr. Hamdan. Can true and associate mangrove species be differentiated since there is discrepancy between the different remote imaging systems? Yeah, this is quite a frequent question asked by many of our counterparts. From my personal reading, of course, we haven't be able to reach to species level, but genus level is yeah, I mean, doable at the moment. Is it true, Dr. Hamdan?
Yeah. So basically, if you want to go further on the classification, so far we only able to classify the mangrove type, which is we are working under the exclusive mangrove species. So for the back mangrove or the associate mangrove, there is some mix in terms of the signature between the other vegetation or the other forest, the inland vegetation, and also the mangrove ecosystem. So basically, this we call it the apa ni? Dia panggil kawasan yang yeah, the buffer between the mangrove and also the inland forest. So basically, we cannot really classify that. But if you have more higher resolution image, and also if you have, for example, a more spectral in terms of the channels, you can do that.
Can that be supported by drone imageries, Dr. Hamdan? Will that be supportive to allow differentiating mangrove habitat with the adjacent habitats?
Yeah, if you have multispectral sensor mounted on drone, that will be perfect for this kind of exercise. But it only covers small region, as you know that if you fly drone, you cannot go 100,000 hectares. 10 hectares, okay.
We need another 1 year or 2 years to finish the work then.
Yeah. Thanks for the question.
Yeah, that's good. So meaning combination of technology available would maybe can contribute to us defining remote sensing study to maybe species or yes, level. Yeah, okay. So that's good. So there you go. Maybe we can whisper to our friends at the ministries, yeah, at corporate organizations, maybe to support this kind of study to strengthen or enhance findings or understandings and the use of technology. Yeah, of course. Now we know of the commercial use and as well as research use of drones. Yeah, not limiting to satellite imageries and maybe topographic map. Yeah? So that's good. I think maybe Dr. Hamdan yourself is expanding your team at FRIM. Yeah? So maybe and collaborating with us, all of us at universities and maybe local communities would also could enhance that effort. Yeah. And next from Prof. Moritz Muller. Yeah, this is also our good friend and he's at Swinburne University in Sarawak. He says, thank you for the presentation. And does FRIM maintain permanent ground truthing sites If yes, would the data be publicly available? So I think this refers to your the 2017 to 2020 study where you did some ground truthing to verify the satellite images analysis. Do you still visit these sites and then do frequent monitoring there, Dr. Hamdan?
So the answer is no. We don't have kind of a permanent ground truthing site because we based on the condition at that particular time. So we visit that at one off, and then we recorded the condition, and then maybe if we want to do that in 5 years or 10 years later, different site will be visited. So we don't have that.
Right, fair enough. But I think I can foresee his idea there, Prof. Moritz's idea there, where actually this would be another good angle that we can look together into, meaning we can collaborate with our friends throughout Malaysia and tally satellite imageries analysis or drone imageries with ground forest structure, for example, and maybe carbon. And I know him personally, Prof. Right, Prof. Muller, I think is looking into pollution, microplastics in the environment. So there you go. I think this is another very good opportunity that we can venture into. There you go.
Yeah, that refers to the sampling plot actually.
Yeah,
so
that's
sampling
right.
plot and ground truthing site is different.
Different, yeah.
So ground truthing site is to confirm the extent and also the condition, but the sampling plot is basically established to measure carbon and biomass or the other biophysical parameters of the mangrove, and that we have that.
Okay. All right. That's good. That's good to know. So I mean, this permanent plot for forest structure, for example, do you have throughout Malaysia, throughout the all the states, or how many do you have, by the way?
Most of them are concentrating in Peninsular Malaysia, but we have a few plots in Sabah and also Sarawak.
Okay. So maybe Prof. Moritz can contact you to get to know on Sabah, on location or sites in Sarawak. So yeah, we can have his team assisting you to monitor that. Yeah, I now that's a confusion using all these terms, right? So ground truthing, it can be anywhere, right? So you get the coordinate, and then you tally it with your with the analysis using your ArcGIS or softwares and whatnot, right? Okay,
correct.
So
yeah.
Fair enough. And how many ground truthing sites would be feasible or should be feasible to verify our remote sensing analysis, Dr. Hamdan, if you may share?
Ground truthing, yeah.
Yeah.
Yeah. So basically, it depends on the nature of the area. So it's going back to the question from Dr. Prof. Harinder right just now. So to confirm whether there is a real mangrove or the associate mangrove. So whenever there is a situation where we cannot confirm this area, then we go there. So for areas that we already confirm on image, that we are confident with the classification result, we don't need to go there.
Any example of such area? Maybe any experience you want to share on this confused site?
So yeah, basically macam dekat in the eastern part of Peninsular Malaysia, because their mangrove is reside on the sandy areas as compared to the west part of Peninsular Malaysia, which is mud flat. So the vegetation also to some extent is influenced by this ecosystem. So tumbuhan macam pokok apa? Pokok pinang pokok pinang pula pokok
Ibong.
nibong. Yes. Nibong basically is the main problem for us because we cannot really identify the distribution and the extent because it's confused with the inland forest.
Correct, correct. Yeah, they may look like all palm, they may look like nipah as well, and then coconut too sometimes, right? Yeah.
Yeah, coconut.
Correct.
Nipah okay because most of nipah plants will be together with the exclusive mangrove trees.
Correct. And of course, there are also confusion with gelam, like for example in Discourse, gelam is always like adjacent or slightly close to mangrove as well. And then of course, I think this also contributes to the discrepancy, like you've highlighted. I mean, if you remember Hamilton and Kesey's that database, they actually put Malaysia as the third largest mangrove holding nation in the world. Whereas Chandragiri and I think Global Mangrove Watch lists us as 5th or 6th. And I think one of the key discrepancy would be like Australia, for example, because they may calculate salt marsh, for example, kan? Salt marsh into mangrove area, and we know the dynamics in between mangrove and salt marsh. So I think, yeah, this may need, I mean, of course, we are now working at national scale, but I think we have to push also this, standardization if we have to, or if we want to, if we may also, because there's so many technologies out there, so many applications, softwares, images, right? Imagery system. So there you go. Maybe some we can work with our international counterpart to come, to get a concrete or solid understanding and agreement on this. And otherwise, it will continue to like confuse so many researchers and readers. Okay.
Because
So
some countries use different definition for mangrove.
Correct. Yeah, that's another thing. Definition by nations and countries. Correct. So some of them, of course, include adjacent habitats as well, and some looks at habitat or habitat level, and some actually look at species level, genus level, and separate different types also. And also, of course, some would count disturbed mangrove area as well, and potential mud flats. Flats that potentially be transformed into mangrove also. So yeah, there you go. So many knowledge today we've learned from Dr. Hamdan. Thank you very much, Dr. Hamdan, and thank you for your time and your dedication to provide us with information. Yeah, we actually expect this. I mean, many of us are maybe familiar with some subtopics within mangrove, but we always learn new things from our friends from different subdisciplines or specializations. Hence, this is the ultimate aim of MyMangrove, because from the beginning, from early 1900s, actually, with Malaysian is very well known for our best management of mangrove forests. Like what you see behind me is Matang Mangrove, which has been managed since 1901. And then it has been studied extensively, and one of the primary reference would be Watson, that was published in 1928, and until the 1970s, Malaysia has always been the central location for mangrove study. And then this is now being supported by young or new generation of researchers looking at all or every angle. So the idea is no one person can actually champion a mangrove research or mangrove habitat or mangrove ecosystem. It needs collaboration in between different discipline, different experts. So this is actually the ultimate reason why MyMangrove was formed, to increase, to encourage or promote collaboration, communication in between experts. Otherwise, each one of us will be working in our own group, small groups, and working in silos, and that would create redundancy as well. So now we know of our colleagues, our counterparts in different universities, different institutions, so we can work together collaboratively. So a few since 2017 when we started off getting to know each other. We see a lot of collaboration in between scientists, in between organizations as well, and this is very good, actually very impactful for reporting by the government, and of course we know Malaysia is signatories to so many international conventions, so collectively we will be able to report to provide better reports, better data presentation to the global communities. So there you go.
Yep.
So speaking of which, let me just quickly. Speaking of which, Dr. Okay, let me just share you again. So this is the poster for this week, this month. Thank you very much again, Dr. Hamdan. We will maybe see you soon. Hopefully, to personally or in person. Thank you for providing us a very good lecture. From basic fundamental understanding to the application, and of course on the specific research you've carried out in relation to mangrove monitoring, identification and mapping. And then of course, so as I mentioned earlier in the beginning of this lecture, we have a series actually. So Dr. Hamdan is the kickstart. Dr. Hamdan kickstarts our series for this year 2022, and as I've mentioned, Dr. Hamdan, as you all know now, is a geoscientist, a geospatialist, and then we will have a series of researchers, experts on different backgrounds. So if you want to know them better, so join us, be with us and follow us to gain new knowledge and understanding. From the remote sensing study to fundamental botany exploration, understanding the genetics, and also flora, and not just flora. And as we know, as highlighted by Dr. Hamdan also, it is also about the fauna and also the physical environment, which actually leads to why there are accretion, there are erosion in mangrove forest. So all of this will be discussed. Of course, not within this year alone, it will be for many more years. And especially for this year, I just would like to share with you on the collaboration that we are actually part of this project with CIMB Foundation. We are so very thankful for big corporation like CIMB and CIMB Foundation for their interest and for supporting and to enhance public communities' understanding on mangrove habitat and ecosystem itself, as well as to promote mangrove conservation and protection through research, education, and restoration. So this is where we will learn as we go on some of the efforts on restoration of mangrove. And we all know also Malaysia is very supportive, very responsive since after the tsunami in 2004. The country actually the country goes all out actually to assist and to restore our degraded mangrove throughout the country. So this is some of the effort. Actually, partly was reported also by Dr. Hamdan just now on some of the degraded location, and some effort were put. And then CIMB Foundation also supports some restoration activity that will be conducted within the next 1 year and 2 years. And of course, that will be recorded as well as part of the research and for educational purposes for local communities, for local NGOs, as well as for the use of other corporate and government authorities. So we welcome actually more support. As we mentioned earlier, it is not just the work of Dr. Hamdan. It is not just the work of ecologists, and mangrove is not only managed by foresters. As some mangroves are actually located within marine parks, for example. So they are actually managed by Department of Fisheries. And we all know also mangroves is very important for to maintain, to sustain our fisheries industries. But we may go for the positive one from conservation to get all of these, or the previous way, the damaging ways, is by turning them into maybe aquaculture ponds, which can be actually compensated through conservation. So there you go. We learn to make things better. We learn from these experts, from our past as well, to manage our resources better. So this is our primary intention. So there you go. Reserve your calendar for all our sessions, and I promise you that we will have good insights. You will receive good insights from all these dedicated researchers like Dr. Hamdan and the rest. And of course, if you are if you want to get to know more, join us. This is free, a networking platform. So you don't have to add Dr. Hamdan or me as your friend. You just be part of this network, and you just share information, and you're welcome to actually share news from anywhere within Malaysia, as well as throughout the tropics. We have actually friends all the way from Europe, all the way from Americas, or also in Australia, being part of us, and as well as many from throughout Southeast Asia. So we share mangrove for the world. We protect and manage our mangrove for the world. It is not just people living in Kuala Selangor or living in Kuantan or living in Tawau, or living in Kuching that benefits from our mangrove. Our mangroves actually contribute to the sustainability of the whole planet. So this is why we are very important. This is where Malaysia is at the advantage to be a key global player in mitigating and adapting to climate change, as well as for the sustainability of our earth, for our generation and future generation. So with that, again, thank you very much, Dr. Hamdan, and everyone for participating today. I don't know if the remaining friends would like to stay and maybe turn on your camera. We can do that in a bit for a group photo as a memento for Dr. Hamdan. And for the rest, for all of you tuning in from on YouTube, yes, thank you very much again. And please spread the word, spread the love of mangrove to your family, to your partners, to your friends, to your colleagues, and to your network within the country as well as throughout the world. So again, thank you very much, ladies and gentlemen. Happy mangroving, and we'll see you again next month in the February 2022 edition of MyMangrove Monthly Discourse with Dr. Ng Wai Loon from Sherman University, Malaysia. Thank you very much again. Goodbye.
Thank you. Bye. Assalamualaikum.